Alright, so here we have a copper wire that is 1.5 meters long. Well, maybe longer than that. We're only concerned with the 1.5 meter long chunk of it. Okay, it's 12 gauge copper wire, which if you look up, tells us that the radius is 1.027 millimeters. Okay? Now we want to know is what is the potential difference between the two ends of this copper wire, or these two parts that are 1.5 meters long. So to find potential difference, we need to know I and R. So to get there, we need to find both of those independently. So let's start with I. We know that there are 10 to the 20th electrons per second. Now, current is charge per second. So we need to convert electrons to charge. And we know that we can convert electrons to charge so by doing 10 to the 20th times 1.6 times 10 to the negative 19th. And the reason that works is because that's the charge of one electron. So if we have 10 to the 20th electrons, we multiply by the charge of one electron, and we get the charge of all of them. And that should give us 16 coulombs, which means the current is 16 amps. Okay, or actually 16 coulombs per second, which happens to be 16 amps. All right. Now we move on to the resistance. Here we got to use resistivity. So if we look it up, we find that the resistivity of copper is 1.72 times 10 to the negative 8. Okay, very low as you would expect in most conductive metals, which copper is very much one. Okay, so then we know that the resistance is equal to the resistivity times the length over the area. Okay? So, we know resistivity, we know length, and we can find area. Area is going to equal pi r squared, okay, because it's the cross-sectional area of the wire. All right, and that's going to come, and putting that all together, 10 to the negative 8 times 1.5 over pi, and we got to convert this radius into meters, 0.001027 squared, and that gives us a resistance of 0.007786. Okay, again, a very small resistance because it's copper wire. That's why we use metal. All right, now for the potential difference, then we know that V equals IR, and we get 16 times 0.007, oops, another 7, 86. 1.25, oopsie, 0.125 volts. So that's actually an exceptionally high answer. There's very little realistic that a 12 gauge copper wire is going to take 16 amps. Okay, it would definitely start to melt. We'd have all kinds of problems. This is actually a somewhat unrealistic amount of current for it to have. But that would be the voltage difference after 1.5 meters if you did have that.